Question number 14, it reads, at every meter on a very thin rod, small air-filled balloons are attached except at the top end. Length of the rod is integral multiple of a meter and mass of every meter of the rod including balloons is 2.7 kg. The rod is lowered vertically into water. Volume of a balloon in air is given to us and it reduces by this amount for every 10 kilopascal increase in the pressure. How much maximum length of such a rod can float in water with its upper end in the level with the water surface? Density of water is known to us. So by reading this question, we came to conclude that let's say this is the water level and there's a water and the thin rod is there. Here the balloons are attached at every meter. Let's say this is here is the first balloon is attached, then second, then third, then fourth, then fifth, then and so on up to n. And this is top, so that means this depth is 1 meter, and the next depth will be 1 meter, then next depth will be further 1, and from 4 to 3 is a 1, 3 to 2 is a 1, 2 to 1 is a 1. So this kind of arrangement is there, and this becomes vertical. That's the question demands for, so we have made it vertical. We need to find how much the length is, or this maximum length could be. So let the maximum length of the rod could be n meter. So if there's n meters, so we can have n number of balloons because it starts from 0. So 0 to 2, that's 1 meter, 2 to 3, that's second meter, 3 to 4, that's third meter. Similarly, n up to this, it will be n minus 1th meter, and the last will become n meters. So total is n meter. So there will be n balloons attached, I just explained. At equilibrium, what's going to happen? Total weight will be balanced by the buoyancy. So buoyancy is going to be equal to total weight. Total weight, we can find it out because for every meter it's 2.7 kg. So let's say that mass is small m, so all will be having a small m mass. It will be n times, so n m will be total mass into g gravity, so that become total weight. Now how to write the buoyancy? Buoyancy will depend on the volume of each balloon, right? So let's say this nth balloon has volume Vn, then Vn minus 1 up to V1. So we will write like a submerged volume into density of water into gravity for the nth balloon, and similarly for n minus 1th balloon, and we'll keep doing so up to first balloon. And then you'll find G would get cancelled out, and we can take this rho water as a common and divide over here. So it becomes Vn plus Vn minus 1 up to V1 is equal to Nm divided by water density. N is the number that we are looking for. So this comes out to be 2.7 divided by 1000 in meter cube, which could be written as 27 into n into 10 raised to the power minus 4 meter cube. So this is the total volume of balloons that we are requiring. Rod is thin, so volume of rod has been ignored. Now there's one more important information, that for every 1000 kilopascal, for every 10 kilopascal increase in pressure, volume decreases. So these volumes are different. Now this goes 1 meter down. So if you go 1 meter down per meter downside, so how much the pressure goes down or decreases? So we write like density rho gh, that's a pressure difference, right? So density of water g into height is 1, so that turned out to be 10 kilopascal. That means for every meter, volume reduces by 100 centimeter cube. So volume of this nth balloon is going to be total volume minus the volume of that has been reduced. So total is going to be, we could write it as a 3000 centimeter cube minus 100, so that becomes 2900 centimeter cube, which could be written as 29 to the power minus 4 meter cube. Now, if we write the volume of n minus 1, then you'll find it will be further reducing by this amount. So it will be like 3000 minus 200, that will become 2800 centimeter cube, or we can write 28 into 10 raised to the power minus 4 meter cube. Similarly, we can keep on doing up to 1. We are coming at the 1, so that will become 30 minus n, because this was 30 minus 1. So 30 minus 1, this is 30 minus 2. Similarly, 30 minus n for the this first one. This will be. Now we can put all these values over here, so it will be like 29, 28, 27, 26, 25 in this manner up to nth level, 30 minus nth level. Into 10 raised to the power minus 4 is equal to 27 into n into 10 raised to the power minus 4. These 10 raised to the power minus 4 getting cancelled out, right? and we need to find n. So 27 turn out to be 29 plus 28 plus and so on up to n turns divided by n. Now if you look this, we can write this 29 as 30 minus 1, then 30 minus 2 and so on up to 30 minus n divided by n. This is a mathematical equation you can solve for n. N turn out to be 5. Now obvious choice is 5 because you know that 29 plus 28 plus 27 plus 26 plus 25. If you do these 5 terms, then average will come as a 27, and that's what we want. So it should be like 5 numbers. That means the balloon should be 5. That means total number of the maximum length that we can have is a 5 meter. That's our answer. Thank you.